88. Oh yeah, so 88. So see how this one stops at 41. So if you go to content, your homework problems that I've assigned are going to come from practice and homework. It's just the way the book kind of set up problems. So if I click homework, it's going to start at number 42. So let's see, 88. Okay. Oh yeah, beautiful. This is actually a little silly, but this actually happens. Why is it so tiny? All right, book. Go home, you're drunk. Oh my gosh, okay. Here we go. Sweet. All right. If you just glance at these, what's your immediate gut reaction? Who seems to be doing better? Yeah, does anybody know this is from? Anybody watch the old cartoons with the Roadrunner and the Coyote? Acme was always the one where anyway, so they have this fake company, Acme. Acme Investments versus the other guy's investments, right? Yeah. Doesn't it look like just an immediate gut reaction, Acme's doing better?
Maybe not.
Right? Your immediate gut reaction, right? For me too. If I saw them, I'm like, oh, Acme's doing better. And then I stop and I look at it, and what's missing? That's really the question. What's missing?
Yeah.
Can anyone tell me how tall this is? How much this is? Is it possible that this is not the same as this? Can we even tell? Is it possible they are the same? Yeah. If they were the same, don't you think they would have put the numbers there? So why do you think they didn't? Because they're not the same. Maybe this goes up to 10, and this goes up to 100. I really want you guys to be with me. If this goes up to 10, then that's like 9 or something, right? If this goes up to 100, that would be 10, 20, 30. I mean, holy shit, this guy's way up above this guy, right? But the immediate visual impact is, oh, they're doing better. You guys kind of with me? And there are people in the past, there are corporations, entities, people that have done exactly something like this. And just sat back and said, yeah, people don't know what to look for. Haha, So we're going to be better than that. We're like, you didn't give me any scale. In fact, what's this scale? I don't know any scale, right? You guys understanding? So part of 1.4, 1.4 has some other definitions, and then it talks about visually misleading tactics, right? So the fact that you can lie with statistics, very often it's you give the data, you just leave out some key things, right? You guys kind of with me? Sort of like when you're on the stand in the court. What do they say you have to do? You have to tell the whole truth, the whole truth, and nothing but the truth, right? So tell the truth, tell me everything, don't leave shit out, and don't include other shit, right? So this left a lot of stuff out. Okay, does that make sense? So there will be a couple of questions about what did these people do to try to mislead you, or what did they leave out, or okay. Maybe. Any other questions?
I have one more question.
Huh?
One more, sorry. How can, on the quiz, how can we determine which one's interval and ratio?
Oh, okay, good. So if I said number of birds in a tree, right? All right, just to make something up real quick. So you go out and you start recording the number of birds in certain trees. Are you with me? Because you're like, ooh, which trees do the birds seem to like, or whatever. Or you got a lot of time on your hands. And you're just like, let me go do this. What level of measurement would that be? Now, can anyone tell me something about nominal and ordinal? What kinds of data are those two? One of the cues, one of the cue words, right? Yeah, that's the definition. But what kind of data? Qualitative or quantitative?
Qualitative.
Oh, yeah, stay with me. What's qualitative data?
Category or
categorical, meaning they're not numerical. Right? So do we all agree that a Jersey number is not numerical in the sense that it's not a real number? If you divide it or subtract it, it doesn't mean anything. It's just a name, yes? Okay. Nominal and ordinal would only be the correct answer if what you're looking at isn't truly numerical. If I say the number of birds in a tree, is that truly numerical? Hell yeah, it's a freaking number, right? Okay. Are you with me so far? So the first thing I would do in a problem, if I say to you, what level of measurement is this? First thing you do is it numerical? In which case it's interval or ratio? Or is it not numerical? In which case it's nominal or ordinal. So now you've already cut your options in half, right? So we know number of birds in a tree is either interval or ratio. If you subtract, if that tree has 8 and that tree has 4, 8 minus 4 is 4. Does that make physical sense? What does that 4 mean? That tree has 4 more birds, so it has physical sense to it, yes? So you might say it's interval because that's what interval is. Remember, interval is subtraction makes sense. But is that the most you can do? Can you do a higher level operation? If you divide 8 by 4, what do you get? And of course, what does that 2 mean physically? That tree has twice as many. So that's ratio. You always go the highest you can. Ratio is the highest level. It's the one you can do the most stuff to. You can divide it, you can subtract it, it's a name, right? So forth. It's everything. Interval means, yeah, you can subtract it, but division doesn't make sense. So what's an example of something that's just interval? We've done one before. Does anyone remember an example of something that's interval but not ratio? Anybody remember?
Oven temperature?
Oven temperature, I love it, right? And that's because 0 doesn't mean what it's supposed to mean. 0 degrees in the oven doesn't mean it's the absence of all energy in the oven. That would be exceptionally freaky. Okay, maybe. Also, what about year that a building was built? This building was built in 1937. This one is built in 1942. Subtracting them makes sense, but dividing them doesn't mean shit, right? Are you guys kind of with me? That's how you tell the difference. So the first thing I would do if I saw a problem, is it interval? What level is this? Or nominal, ordinal, interval, ratio? I'd say, is it a number? If it is, it's interval or ratio. If it isn't, it's nominal or ordinal. So then I can really focus my thought process. And on those problems, I'm going to ask you why. So you can give an example. You can say exactly like I did. 8. Let's say there's a tree with 8 and there's a tree with 4. 8 divided by 4 is 2, twice as many birds. Leave me alone, Jeff. That's it. That's all you got to say. That's why it's ratio. Are you guys with me? No? You guys all right? Okay. Any other questions? Because I know everybody started the homework, right? Worst you can do in a math class is get behind a homework. Yes?
I was going to say that can't it also still be nominal even if it's a number? Like your student ID would be nominal?
So that's not truly numerical, right? It's still just a name, right? So what I mean by truly numerical, you can do computations with it. Yeah, I like it. Just like I said, Jersey number. That's not truly numerical. It's just a name. Okay, I like it. Okay, anything else from homework stuff? Is everybody able to find the homework okay?
Yeah.
Let me know if you can't. If you don't want to say right now, just come up after class. Because if you can't find the homework, it's not good. Right? It's going to be hard to do it. All right. And also, just to remind you about a few things. I think a decent number of you have done the survey. So if you haven't done the little survey yet, I just ask you, please go in and do it. If you don't do it, I'm not going to take points away or something, but just take a second to do it. It's only 12 or something questions. Just to remind you guys, there's the link for tutoring. So it's got all the different forms of tutoring that we offer and some links to them. There's my office hours and locations where I am. I teach one more class, and then the other time I'm in the Math Study Center coordinated tutoring. So I am at 3 different locations for office hours. So you can kind of track me there, right? Of course, you guys can't see this yet. You're looking, But I will put a practice test up there when we get to that point. When is the first test, by the way?
21st.
The 21st.
Yeah, 2 weeks from today, right? A week from today is, of course, Valentine's Day. And then another week after that is our first test. Yay! So on the 16th, I'm not going to do anything new. We're just going to have a review day. I'm going to give you the practice test and the answer key. It'll be a review day on the 16th. Okay. So any other questions about process or homework questions? Okay. So the very first thing I want to do is kind of pick up right where we left off. And I think the last thing we did last time was talk about something called frequency distributions. And one thing about a lot of mathematics is sometimes the words get in the way. The actual process is easier than the word makes it sound like. So let's do this. Let me see. One of you guys are really young, so let me not do that one. Oh, I already did that one. True. All right, so let's do this. Let me just make up some data. I'm going to give it to us in order. Oops. All right, let's see. 2, 3, 4, 5, 6. Let's make it 18. There. Okay. So copy that data down real quick. I wanted to bring the calculators, and of course I forgot, because I want to show you. I might be able to go grab some from some colleagues right there in a minute. I want to show you how the calculator can do a very basic thing for us. Put a list of data in order, right? One thing that really sucks to do by hand is to try to order a bunch of data. So it's much nicer you just put it in, hit a button, bam, it's in order. So I want to do a couple things. I want to kind of create this last problem somebody asked me about, where it was like, yeah, it was something like this. It was a range of things. I think it was number 16. Yeah, see how they have these, what we call classes. They have these classes here. So in section 1.3, they introduced the idea of a frequency table, which is just, you freaking count the number of data points here, right? We did one like that last time. Then relative frequencies making a percentage and so forth. So section 1.3 introduces that idea. Section 2.2 makes a visualization out of that. And we talked about it at the end of class last time, and that was called a histogram, right? So if I say bar graph, is everybody cool with, can you visualize a bar graph? So real quick, a bar graph is for qualitative data. Qualitative data. So if I asked people what kind of car do you have, Ford, Chevy, Hyundai, whatever. Right, this is a bar graph. Okay, maybe. So bar graphs, we know bar graphs. Are you concerned about the gaps here? Do those gaps mean anything? No, this is the Ford bar, this is the Chevy bar, this is the Hyundai bar, right? Which sounds like a really weird experience to go to a Chevy bar. But that's the bar just for the Chevys and so forth. So the gaps don't mean crap, yes? What if I had put BMW and, what am I missing? Kia? Right. What if I did this? What does this mean?
There's
no BMW, okay. All right. That's for qualitative data. Is anyone concerned about the fact that this is not, is this supposed to be in some kind of order? This here? No, it doesn't matter what order that's in. Okay. If I have numerical data like this, can I just put the numbers anywhere they want to be? No. So they have to actually be in order, right? Because this is ordinal data. This could be the age of people at a bus stop or something. So I'm a little concerned about that. Hopefully that person is with somebody, right? Okay. Let me stop for a minute. Okay. So what I want to do you notice how there's not a lot of repeats up here? What's the only numbers that are repeated?
20, 15.
20 and 15. So it wouldn't make real sense to have a 4 and a 9 and a 10, because then the bars would all be little tiny bars, and then a couple will be high. That doesn't make any sense. So I'm going to group these things together, just like they did here. So here the frequency would be the number of data points that are between these two. You with me? So one question we might ask is, why the hell did they pick 0.5 and 6.5? Where'd that come from? Why did they pick that? So we're going to talk about the math behind that. So one thing nice about these trailers is I can use the walls here in a minute. I'm about to try to explain the physical idea behind the math we're about to do. So I'm going to seemingly go off on this crazy tangent. Just go with me. Let's say that this, from here to the door, let's say it's, I don't know, 30 feet. It's probably about 20 something, I don't know. Let's just say it's 30 feet, right? And let's say I want to, so these panels, how do they figure out, let's see, how wide these panels have to be? Are you guys with me?
Yeah.
Like if I wanted to use 1, 2, 3, 4, 5, 6, 7, 8, 9, let's just make it 10. Just if I want to use 10 panels to cover 30 feet, it's a relatively easy question, right? How wide would each panel have to be?
3 feet.
3 feet. Is everybody cool with that? If I'm going to cover 30 feet's worth of space with 10 panels, of course they have to be 3 feet wide, right? Is everybody with me? I love you guys. You're all looking at me like,
Yeah.
okay. So somehow this is going to relate to what we're about to do. Can anyone tell me how wide, what's the range of data? How far does the data range?
36.
Yeah, the range is officially high minus low. So you could say the range, it goes from 4 to 40. But the range is officially a number. It's the distance. Okay. So here, obviously, like you said, the range is 40 minus 4, 36. So that's exactly like the 30 feet. That's how far I've got to go. Okay. And the beautiful thing about these slats on the side of the rooms is that looks like, I'm going to want to make something that looks like this. So do you see how it's physically, I want to cover this much space with so many slats. So I can figure out how wide each one has to be. Here, how wide was each one?
6.
6. So they figured out the width had to be 6 to cover all the way down to the end. Let me stop for a minute. I always want to try to show you the physical idea behind the math. Because what's the worst thing about math? Very often it's abstract. I don't have a connection to it. Here you can just look at the frickin' wall and go, oh yeah, it's just covering. So I want to figure out how wide each one is so I can cover it all, right? So let's say, now here's where we're going to be able to choose something. We can choose how many rectangles we want. Sometimes I'll tell you, but like on a test, I'm going to let you choose. So let me tell you right now, the number of classes, which are, Jeff, I love you. Number of classes, you can also look at this as saying the number of rectangles, the number of bars, has to be between 5 and 10. When do you think you might use 10 classes versus 5 classes? When would using 5 classes be bad? So if my data was, or one would using 10 classes be bad. So if I had 8 data points, would I want to use 10 classes? Probably not, because then I'd have just a bunch of little bars and it wouldn't tell me much. So the bigger my sample is, the more classes I want to use. Does that make sense? Because then the more data I've got to go in all those bars, right? We're most likely going to use 5 or 6 for us. Okay. So most of the time, you guys are going to use 5 or 6 classes. Why? Because I'm not going to give you this big ass sample. Because then that just becomes busy work, right? If I give you 180 data points and you have to sort it, do all the stuff to it, that's silly. Yes? You guys agree? Or do you want me to give you 180 data points? Okay, that's what I thought. So most of the time we're going to have a relatively small sample, so most of the time we're going to use 5 or 6 classes. And again, the classes are like the number of rectangles. So remind me, if I know how far I want to go, and I know how many things I want to use, how do I figure out how wide each one has to be? So when it was 30 feet and 10 slats, how wide was each one? 30. How far I had to go, divided by 10, the number I'm using. So if we use 6 slats, right? How far do we have to go in the data? How far do we have to cover? 36, right? You have to go from 4 to 40, that's 36. And I want to use 6 classes. I want to use 6 rectangles. I really want this to make physical sense. 30 feet, 10 rectangles, each rectangle 3 feet to cover it. Makes total sense, yes? If you made them 2 feet, you're not going to cover the whole damn thing. It's going to be bad. It's going to be rain coming in and shit. Come on, right? Not a good look. Okay. So here, the class width is equal to range divided by the number of classes. So this is going to be 36 divided by 6 is 6. That's crazy. A little bit of a coincidence we got 6 and they got 6. All right, let me stop for a minute. You guys doing okay so far? Now again, did I have to go through the whole physical interpretation? No, I could have just told you, here's the formula, right? But I want you to have a physical connection with it. It's not just some abstract math thing. It's actually doing something physical. Okay, now we come to a decision point. I'm going to show you the textbook method first, and then I'll show you the way I do it. Yes?
Sorry, can you repeat how you got the denominator, like the 6 again?
So in this case, so on a quiz, I might tell you to use 5 or use 6. I might tell you how many classes to use. So here I told us we're going to use 6.
Okay.
You could have used 5 instead. Now real quick, I was kind of arguing with myself which one to use. If you had used 5, what is 36 divided by 5? Here's a beautiful way to divide by 5.
7.2.
Double the top. What's double 36?
72.
Because if you double the top and the bottom, you're dividing by 10. And dividing by 10 just means move the decimal back. Now why does that kind of suck? Do you want a 7.2? So normally if you get a decimal, you just round up to 8 in that case. So you would make classes that are 8 wide. You guys with me? But in this case, I gave us 6. I want to make a specific point with when we get a whole number. I'll show you. So that's kind of nice. If you do get a decimal, just round it up. Okay. All right. So yeah, this guy, either I'm going to give it to you or I'm going to say choose your own. Do not choose 10. It's going to probably be too much. So now I've got to construct, I basically want to make exactly that table. So I have to figure out what each class is going to be. I'm not going to worry about the cumulative relative frequency. It's not going to show up too often, but in the homework you got to do it. You got to know what it means. We're not going to use it a ton though. Okay. the way you normally handle the class, there's two main different ways. And there's a way I was taught, and then there's a way that most books seem to do it nowadays, right? And the old man up here talking, back in my day we did better. So I'm going to show you both ways, and you can pick whichever way makes more sense. So I showed the textbook method first, because you can go back to the book and kind of get help with that method. What's the lowest data point? 4. If this class starts at 4, and the width is supposed to be 6, where should the next class start? 10. Right? That's simple. You with me? If I put a 10 here, why is that a problem?
Because then you don't know if the 10 goes in the back.
Because then, does a 10 go in the first, or does it go in the second, right? So I've got to put a 9 here. So one thing I don't like with what they did, we'll get to the point of what this really means. I wish they hadn't done this, because this is really technically wrong. You're going to love it when a book does that. And again, it's free, so, you know. I'm going to show you what these numbers mean in a minute. Is everybody cool with what just happened? I want you to really, why could I not put a 10 here? Because then where would 10 go? If there was a 10, where would it go? So I go to 9. What does it look like this is, the width here? What does it look like it is now?
It looks like it's 5.
It looks like it's 5. But it's actually, well, 4, 5, 6, 7, 8, 9, 6. Okay, sweet. And there's a better way than what I just did, to be honest. What I just did was a little weird, but there's a better way to see it. Okay, is everybody with me so far? So, I'm hoping this makes physical sense. The width that they have to be, how wide the rectangles have to be, just to cover all the data. Normally, you're going to start at the first data point. You don't have to. And then, you just add the width to it. Now watch what I can do now. If this ends at 9, this one has to end at 6 later. So then I just keep adding 6 down. So add 6, and then add 6, add 6, and then add 6. And 6, and then add 6. Did I add right? That would be awesome if I did. 6, 6, 6, 6, okay. Bunch of 6s. And then add 6. And then add 6. Now what's wrong with that last? What's the highest data point?
40.
And how far did our 6 classes go?
39.
Shit. Okay. Anytime your class width is not a decimal, because if it's a decimal, you round up. And can you guys understand? If I round up, aren't I going to end up over covering? Isn't it going to, if it has to be 7.2 and I make it 8, aren't they all going to eventually like over cover? So what I just cut a little bit off of the last one, right? So it's okay to over cover the data, but it's no good. Every data point has to have a place to go. So in the case when your class width is a whole number, you're going to have to do this, and this is the one time you're allowed to do this. You just suck that last data point in. And this is a reason why I don't really like this method, and I'll show you the other method. But is everybody with me so far? So again, where do you see the class width? You don't see it here, you see it here. That is the weird part. The rest of this is easy, thank God. Right? That is the weird part. The rest of this is pretty simple. Yes?
Wait, why is it 40 and it's adding by 6 each row?
Because if I went by 6, how many classes do I have up here? I have 6, right?
Yeah.
I don't want to make another class because I said I don't need to use 6 classes,
Yeah.
right? This is the one time you're allowed to change that.
Okay.
You got one data point kind of hanging out right next to it. You might as well just take it in.
I was confused, that's why.
I understand. You could make a 7th class, but that's kind of like not what you wanted to have happen. When will this happen when this is a whole number? How often will this be a whole number? Not very often. Okay, maybe. So if we would have stuck with 5 classes and we would have rounded up to 8, that would not have happened. Okay. In fact, real quick. Side note, if we would have done 8, this class would have, if I add 8, that's 12. And so this has to be 11. And then if I keep adding 8, let's see where this goes. 20, 28, 36, 27, 35, 43. Do you see how that goes way past 40? So then every data point has a home. Do you also see how this does not have to be the last data point? It just has to have a place to go. Okay, I love it. How you guys doing?
I have a question.
Yes.
So when number of classes, 5 or 6, when we do the classes, does it have to be like 5 actual like groups kind of?
Yes.
Okay.
Good. Now, again, if you made a 7th class, it's not terrible because it isn't some grand universal thing saying, thou shalt use 6, you know. So if you use 7, you're not going to anger some god somewhere, right? I don't think so. Fine. Okay. So, all right. So, the rest of this problem is relatively straightforward. Now I just have to count. Somebody help me out. How many data points are from 4 to 9?
2, 6.
2. So actual data points. Otherwise, these would all be 6. All our bars would be the same height. Doesn't make any sense. There's only 2 people that fell between 4 and 9, yes? What about 10 to 15? 4, right? So this is easy. This is just count. Frequency means count. 4, 16 to 21. 5. 22 to 27. 3. 28 to 33. 1, right? And then 34 to 40. 3. Okay. Love it. I love it. Not too bad, all right? And again, you see these freaking graphs everywhere. It's kind of nice to know what goes into making them. And we could change how many classes we want, which would change the look of the result. So somebody could purposefully pick the number of classes to make it look a certain way. That's another way we can kind of misrepresent. So how do I make relative frequency again? What do these add up to be?
18.
18. So what is this relative frequency?
2 divided by 18.
2 out of 18, which is?
11.1.
Yeah, so we're going to make it 11.1%. I love it. Cool. Let me see if you guys are close with this. Do you see how 4 out of 18 should be twice that? So I don't need no freaking calculator. 22.2%, right? 5 out of 18 gets a little more interesting. Anybody have that? Yeah. 27.8 roughly. 3 out of 18 is 1/6, comes out to be 16.7% roughly, and you can double check me. All right, so sweet. So this is the weird column. This is the column that takes all the work, and then these 2 columns are really quick. Just count and then divide. 1 divided by 18 is, I believe, 5.6%. And then 3 divided by 18 again is 16.7%. Okay, cool. Can somebody really quickly double check what we just did? What's the quickest way to check what we just did?
Add them all up.
Yeah, if you add up all these, good. Just take a minute and add these all up here. Yeah, I can do that. Yeah, okay. Should come out to like just the barest sliver above 100. Yeah. Does that mean we made a mistake?
No.
No, we just happen to round up more often than we rounded down, so it's perfectly fine. So it doesn't always have to be exactly 100, depends on how we round it. All right. How you guys doing so far? You're like, oh, Jeff, this is so exciting. You can barely sit here. Okay. Don't worry, eventually I'm going to shut the hell up and let you guys try some problems. Just want to give you some examples. Okay. So, I am going to erase this here. We don't need this anymore for the moment, so I can make the picture So I want to make a relative frequency histogram. So I need this scale to come from these numbers. Do I need these numbers to show up on that scale? No. How far up do I need to go?
40?
What's the highest percentage?
27.
We're doing relative frequency, right? So I don't care about these guys. I care about these guys. The highest percentage I see, 27.8. So maybe go up to 30, right? So what kind of scale do you guys want to use? You want to go by ones? Please say no.
3s?
Threes, 11, fives would be good, yeah? 5, 10, 15, 20, 25, 30. Woohoo! So when you make a scale, it's got to be consistent. Every step has to mean the same thing. You don't have to have any of the data points show up. They just have to have a place to go. Now here's where things get weird again. All right. I don't know if you guys agree with me. This step here was a little weird. Yes? Making the classes a little weird. These two steps easy as hell, hopefully, right? Now we get weird again. Because if I do this, 4, 9, 10, if I try to actually just make those, I'm going to have a gap here. If I see a gap in a histogram like this, that tells me there's nothing in here. It doesn't make sense because are any of these empty? Every single class has something, so there should be no gaps. Okay, I love you guys. Okay, so here's where they got those numbers. Here's where those numbers come from. All right, let me get a little weird with you guys. So there's a limit. Just go with me. Go with me on this, if you would, please. And you're like, that's all we do. There's a limit to me. Jeff stops here, right? This is not Jeff. This is Jeff. So there's a limit to me, correct? I also have boundaries. If you step inside of that boundary, I better know you, right? I better know you. I better be close to you. I better all the stuff. You don't step up like right here. Is it you guys with me? I know this is weird. Just go with me. Isn't there a limit to where I am? Jeff is not here. Jeff ends here. Yes, there's a limit to me. And then there's a boundary that I try to maintain. I love you guys. You're all like, all right, math dude, do your weird shit. There's a boundary to me. Yes? These are the class limits. They put the class boundaries. Now again, why would there be a gap? Because this first class stops at 9 and the next class starts at 10. That's why there would be a gap. But what if we go down by a half and up by a half? Down by a half and up by a half. Then they would line up, right? And again, I'm going to show you, this is the textbook method. The way that I do things, you don't have to do this. So I'll show you that second. But I just want to show you where the book got its numbers. Now real quick, see these numbers in blue? You don't put those. I'm just putting those to show you where they're coming from. So then what would this actually be? 3.5 up to 9.5. And then the next class is 9.5 up to 15.5. And then of course you just keep adding 6 because that's their class width. Right? So add 6. Add 6. Add 6. And then this last one's a little weird. Remember? So it kind of sucks when you get a whole number because you got that last number is a little weird. Let me finish this. I'll go back and show you the other way to do things. And then I'm going to give you guys some work and I'm going to shut up for a bit so you guys can work. Okay. So let me finish this. So now this is easy again. How tall should this class be? 11.1%, right? And of course, we're doing this by hand, so it doesn't have to be perfect, but it better go just a little bit above 10. Right now, it's relatively easy again. The next class should be to 22. The next class should go up to 27.8, so closer to 30 a bit. Oh shit, move that over. There we go. these should be the same. Oh, well. The next class should go up to 16.7, so almost 17, so about right there. The next class should be almost 6, so about right there. And the last class should go up to, what does that say, Jeff? 16, 17, so about right there again. There. There's one thing missing up here. That was also missing in that one example about the Acme thing. So we're better because we got a scale here, but why does the scale still suck?
They're not labeled.
Not labeled. Does somebody remember what I said this was? It's the ages of people at a bus stop. So it's exactly what you put down. Ages of people at a bus stop. So with this quick visualization, what is the modal class? Which class occurs the most? Where does people seem to cluster?
15.5.
Yeah. From about 15 years to 21, 22 years, right? That's where people seem to be focused, which kind of makes sense. And then of course it goes up again in the older years. Okay.
Oh, what does it say there again?
Which one here?
Uh-huh.
Ages of people at a bus stop. Oh, yeah. So that is a completed relative frequency histogram. Scale, scale, consistent. Label, label, no gaps unless there's an empty class. If one of these had 0, that would be an empty spot. Okay, I like it.
When we do this, do we have to do like 9.5, 10, like?
Oh, let me show you the other way. Okay, thank you. So real quick, I left myself no room. Let me see if I can do this. So this is all done. If you're okay with this, this is all done. You could do it this way. You're done. Beautiful. Or, and the reason I'll show you why people don't like this way. I could define the first class to be this. People don't like that because it's got not interval, but it's got inequalities in it, so forth. So what does this mean? It includes all the values that are at least 4 up to 10, not including 10. So then the next one would be 10 to 16. 16, you can line them up, Jeff, that'd be great. 16 to 22. Do you see how 16 does not go here?
Yeah.
But it does go there. And then the really nice thing, if you do it this way instead, then here would be 4. You just use these 4, 10, 16. Much cleaner, right? You could do it either way you want to. Yes?
But on your last class, you would have to also do including 40.
Yes, exactly. So when I get to the end, I'd have to make this inequality less than or equal to. Exactly. But at least the 40's there, and then it makes more sense. It's just barely out, so you just stick it in. So let me do this. I want you to actually do number 4 first, the one about, believe it or not, shampoo. Thank you. You're welcome. Do number 4 first. I'm going to go try to grab some calculators so that we can go back and do number 1. Yeah.
Okay, so we have to run.
At least, so they don't have to get it, everyone behind.
So you would just look at like this one,
540.
so everybody at 12.
Yeah, so that's two people that assume you guys. So you just see what's acceptable. They can, that's a hundred, that's a class three. So
Class three is okay. So the, yeah, okay.
that's one class, like, you know, that's what will be the percent.
Oh, I got you.
Alright guys, let me take a look here. So there's 11, 6, 2, and then this is half of that guy, so that's 1. So how many total people?
20.
20. Okay. How many classes did you guys get?
I counted 6.
Yeah, 1, 2, 3, 4, 5, 6. How many? There's 2 that are empty, right?
Yeah.
Okay, so there's 6 classes. And what's the class width?
20.
You can see it's 20. Yeah. Big ass. So kind of like this kind of problem because it's going backwards. You have to be able to construct your own, but if you're going to construct your own, you have to be able to deconstruct somebody else's. You have to understand what you're seeing in that histogram they're giving you. And then the last question. So those should have been relatively straightforward. And then the last one, real quick. We're going to see the phrases at least and at most quite a bit in this class. So when I think about those things, if you have to be at least this tall to ride the ride, right? Have any of you guys ever gone to an amusement park? Have any of you guys ever ridden a roller coaster or something, right? And have you ever seen the thing that says you must be at least this tall? And I remember young Jeff is like, someday, right? I still remember the day I was finally like there, and I'm like, yes. Okay. So you have to be at least as tall. Can you be shorter and ride the ride? No. So at least means that or more, right? But our brain sees the word least, I think, and it goes backwards. So at least means that or more. At most means if you can be at most 12 to eat off the kids' menu at Denny's or something, you can be 0 to 12. At most means that or less. Okay. And again, I know some of you guys are like, I know what that means, but some of you guys are like, oh, okay, sure. So we're going to see that often enough that you have to know what it means when you come up across it. So this last question says, what percentage of the sample has shampoo that lasts at least 40 weeks? Well, how many had shampoo that lasted at least 40 weeks? 3. Out of. So anytime you need to make a percentage, it's the number you're looking for, 3, divided by the total. Yes.
20.
Beautiful. 3 out of 20 people. 15%. So you can just multiply by 5, make it out of 100. That's beautiful. Kick ass. All right. And that would be, anyway, that would be me. It lasts for a long time. I don't use a lot. I don't have a lot here. So, okay. 40 weeks, that's quite a bit.
10 months
I
for
know.
a bottle of shampoo.
Yeah, well, how big is that bottle of shampoo? It's pretty big. It's like a Costco. So what I want to do, let's do this. Okay, let's see how this is going to work. If you need to borrow a calculator from me, what I need from you is either an ID with a photo on it, or even something valuable like your phone or something, right? So how many guys need to borrow a calculator? Anybody need to borrow a calculator? Come on up here, bring up photo ID or like your phone or something.
Give you my debit card.
Sweet. Fantastic. I'll be on the computer doing unrelated things as you guys are working.
Yeah, there's not much on it. It's like $5.
Oh, okay. Well, hey, still $5. Thanks, man.
Which ID do you want?
And back in the day, I used to just give calculators out, and then they were dwindling, and I had to pay for the replacement. So I'm like, no. Ooh, dude, it's like go fish. Make sure that they turn on before you get too far away. Okay, good.
I forgot I had a state ID.
Oh, sweet. Thanks, man. All right, everybody else has a calculator? And when I say a calculator, I mean a TI graphing calculator. A regular old calculator ain't gonna cut it. Poor little things. Alright, is everybody set? Oh. Oh, I forgot to check. Oh, let's see. Thank you. Ooh! I was just there for the first time. Okay, let me see. Oh, sweet, thank God.
Someone's been duped. Someone's been.
Oh, you've fallen prey to my master plan.
Someone's been scammed.
Thank you. Poor little guy. Oh. Shirt turns on. Yep. Got it now. Turn on. Yay. Oh, neato. Sweet. Oh, sweet.
It's easier than you actually sort it. Sorting is the one thing.
Alright, you turned on, but you're weird. You have the best possible way. Alright. Oh. Well, that was neat. Maybe give that one. You've seen some shit. Okay, let's see. Poor little guy. Thank you. You're welcome. Alright, I had one left. Alright. So let's do this. The most basic thing that we're gonna have to do with data is sort it. And thankfully, this calculator is able to do that. And thankfully, I have a computer emulator, a TI emulator program on this thing.
Is that free?
No, I don't want to help. I mean, okay. Alright, so what do I not need? I don't need to see key press history. Okay, good. So very first thing I want you guys to try, let's just do some basic math. Because how many guys have actually, this is your first time ever like doing anything with a TI calculator? Anybody? So has everybody done some stuff on a TI calculator before? Okay, okay. So just to show you a couple really, this semester this is going to come in really helpful. So everybody do this for me. Do 4 minus 6.5 divided by 11.17. See if we all get this. That's my favorite number, by the way. I'm joking. Yes.
I'm just like that.
Oh. Okay. I was told they were good, but apparently not. Okay. So everybody got that number?
Yes.
Let me show you a couple of really cool things, because this semester we're going to be dealing with these rather large formulas. We're going to get a number, and then we got to do more stuff with it. Stay with me, guys. The worst thing you can do in mathematics with a number is round it when you're not done using it. You guys with me? If you round a number and then you do more stuff with it, it's sort of like being in a boat and being 1 degree off course. Later, you're going to be way far away from where you're supposed to be, right? So if you round and you continue to go, you're going to propagate that rounding error. It's going to get worse and worse and worse. So what that means is I don't want to freaking put all those decimals in every damn time I got to do something, right? So what if I had to take the square root of that? Well, get the square root button. Everybody see the square root button? Right above the square. And then here's one of the best buttons on this thing. Right above, yeah, exactly. Right above the negative button down here. So if you hit second, negative. You guys with me? If you hit second, this is like your shift key, right? Second, negative. The answer means the last number that was on the screen. It's like a continuously updating memory location. And trust me, that's cool. So you hit that, bam. Okay. Incredible.
I don't have this square root thing.
Oh, yeah. No. You hit this. No, you do.
I don't have an ID with me. I don't have a driver's license.
The square root button somewhere?
Yeah, are these the square root?
There it is. Well, that's a cute. There. What does that say? It's too tiny for me.
There.
Let me. Here, Nico.
I don't want to take out. I don't have an ID with me, man.
I know. where you are. You won't get far from me. Do I have my own calculator? No. So I don't even have one for you. I'm sorry.
Oh, we can share.
Yeah, kind of
Wanna share?
look on with each other.
Oh, yeah, sure.
All right, guys.
Wait.
Something else I want to show you that could come in handy. Do you see the little stow button down here? It says stow. In fact, let me make this bigger. Oh, where are you? Look here, Jeff. There you go. Oh wait, I can just do this. That's right. There. Down here it says stow.
Yeah.
So if you hit stow, so that's obviously means store. I can store it right here is your all-purpose variable button. So I'm going to store it in X. So now if I needed to do a bunch of shit to it, I could do like 5x squared minus x plus x to the third power. So every time I see an x, it actually has that number in it. Enter. Okay, that's what it would be. Crazy sauce. Maybe? Alright, so that's really cool. That immediate memory location of answer right above the negative button. And then you can actually control memory location. And we're not going to have to do this, but do you see all these letters? Every single one of them, if you hit the alpha button, you could actually use every single one of these as a different memory location. So like I could store, I could take 5 and store it in alpha A. So now if I just hit A, that's 5, right? You guys sort of with me? Crazy sauce. And if I hit, okay, you guys get the idea. So those kind of things will be helpful. Now, can anyone tell me, just to get silly for a second, what's the button we're probably going to use the most on this, besides on? Exactly. What's the next button we're going to use most in this class?
A stat?
No way. All right. Ooh, now I would have accepted math. That's pretty good, but we're more specific. So we're going to use, if you just hit stat, this is where we're going to be able to input data for the calculator, and it can just chew them up and spit out statistics at me, right? Now you've got me as a teacher, which means in the early going especially, you're going to be doing a lot of stuff by hand, and then I let you check it in the calculator. You're not able to just pull the number out of the calculator, because then your calculator passes the class and you retake it, right? It goes on to have a great life, has little calculator babies, and you're stuck retaking statistics. So don't tell me what some past stats teacher let you do. I don't care. So we're going to be doing a decent amount of stuff by hand, but I do let you check it in the calculator, and we will get to a point where we're going to do a lot of stuff in the calculator because the computations would just take way too long by hand, right? But in the early going, we will do a lot of stuff by hand. But one thing we can let the calculator do for us is just chew up on some data. So if I hit stat and I hit edit, that's where I can put stuff into the calculator to do. So later we're going to have more than one variable happening, so we're going to be using more of these lists. But right now, for number 1, if you look at number 1 on the sheet, do you see all that freaking data? I just want you to take a minute, and of course this is the most exciting thing about statistics, besides listen to me freaking drone on and on. The second most exciting thing is putting data in, right? So just take a minute, everybody. And everybody see the data, 66? Just put it in, 66, 89, so forth. Shit, Jeff. Maybe put it in correctly. There you go. Let me do it this way. Let me know if you're not sure what we're doing. should have asked you guys if anybody had data in your list already.
Yeah.
So if you have like, there's a list with data in it, just go up to the list and then go and just hit clear. Never go to the list and hit delete. Watch what happens if I hit delete. Oh shit, list 2 is gone. Shit. So then you would just hit stat, setup editor number 5. And then it'll be back. Come back in. Yay. Okay. So has everybody got all that data in your calculator? Not yet? Okay, keep going. Once you got all your data in the calculator, you hit stat. Now what do you think is the difference between sort A and sort D? Ascending, descending. So we're going to do ascending, meaning from smallest to largest. And do you see how it needs an input? What's right above the number 1 on the calculator? L1. So you hit second 1. You're going to sort list 1. And then it's very anticlimactic. It just says done.
Wait, so 2, 1?
Say again?
Wait, how you get
2,
to
1.
No, it's shift 1. Anytime you need a blue thing, you hit the second one.
Do you hit them at the same time?
No.
Or just-
Alright. Anytime we have a day like this that involves technology stuff, let me know immediately if you get a syntax error or something goes crazy. Is everybody doing all right?
Why do you not have an ID? That's called free to drive. To get a real ID.
I'm free to drive.
How old are you?
19.
I'm used to using.
No. Yeah, I'm gonna put you on the app store and get the real ID.
It goes, it starts 20.
You need an ID though. The cop pulls you over and stops you. You don't have ID.
Well, I'm not driving. I'm not the one driving.
I'm just saying, like, say.
So now if I go back, if I go back to my list, right? Hit stat, edit. It should be in order now, right?
Yeah.
One of the most fundamental things to do with data is sort it. So thank God this crazy expensive calculator can do that. Now, what I want you guys to do, I'll let you work in a group if you want to or not, and just keep going with number 1, right? So I got you through the first step. You got the data in order. Now I need you to make a class width. I need you to set up your classes. You need to get the frequency right. Finish up number 1 on this worksheet.
Do you want us to write down the sorted data? Do you want us to write down the data in order?
If you want to. I'm not going to collect these sheets. These are just for you. So. So go for it.
Aren't you like 21?
Keep going here. Right? Feel like we just did a minute ago. Guys, what's the name of this? High minus low. What's the name for that? Range. I like it. So finish this problem up. Do number 1.
I have a question.
Yeah. All right, guys. I'm going to kind of catch up to you. A little bit up here. So we all got a class with the 4. Now again, I prefer it this way because I can see the width this way and this way. The textbook method is weird 2 ways over. I can't see the width this way, And then I also have to adjust these when I go to make the history. So it's up to you which way you want to do it. Looks like most of you guys are doing it this way, so that's what I'm going to do up here. We all got up with the 4. The first data point is 61, which means the next class should start 4 later to be 4 apart, which means this one's got to be 64. Now, the minute you got that set up, you're golden. You just add 4 down until you get to the last class. Add 4, add 4, add 4, add 4, add 4, add 4, add 4. Okay. Now, just to really make a point of this, what's the highest data point? 79. This went to 80. Who cares? 79. Does it have a place to go? That's all that matters. Right? I don't care where this ends. Just each data point has to have a place to go. Right? We're building little homes for these data points. We want everybody to have a little home. Okay, how are we doing so far? Not too bad, right? And the nice thing, again, one nice thing about this kind of stuff, do you guys see these kind of graphs every now and again out in the wild? Has anyone ever seen a graph like this out in the wild at all? Oh, I love you guys. You're like, I actively avoid that shit, Jeff. Thank you very much. If you do, it's good to know what goes into creating them so you're able to interpret what it's telling you better, right? So now, frequency, another name for that is just count. How frequently did data show up? So from 61 to 64, how many showed up there? I lost my list. There we go. Yeah. Dose, I love it. Do. So then the relative frequency there would, well, let's just do this. What about the next class? What'd you guys get for the next class? 11. 11? Okay. I'm going to outsource this. So 11, oh shit, half. Whee! That looks about right. And then 69 to 72. 13? 13? 73, 76? 7? 77 to 80? 2. Does that look right? Sort of outsourcing that, okay. And of course, one quick check. All right, I know there's supposed to be 35 of these. So 26, 28, thank God it adds up to 35, right? Worst thing in the world is if that's not 35, you know, oh crap, which one did I miss? Okay. Now real quick, if you're running out of time on a quiz and you notice that's wrong, just calculate everything with that number and just put a little note. I didn't have time to find what I did wrong, because I'm not going to take a bunch of points off for just putting in too many numbers or missing one. That's a human error. That's not a conceptual error. Does that make sense? So as long as you show me you got the concepts down, if you make a little mistake like that, that's not huge. But at least it's say, I know this wasn't right. I didn't have time. No problem. Right? You might lose 1 point. Relative frequency. How would I do that for this first guy? 2 out of the total. I think that was 5.7. So then 11 out of 35. 31.4. I think so. Seems about right. Yeah, that's got to be right. Yeah. Okay. And then 13 out of 35 will actually be 37.1.
Yep.
Yeah. Holy crap. Okay. And then 7 out of 35 is nice because that's 1/5, which is 20%. And then 2 is nice because we already did it. And what do you get when you add all this up? 99.9? Yeah. And that is good. So when is it bad? If you get more than 0.2% away, I'd say that's a problem, right? If you get 100.7% or 99.2%, something went desperately wrong. You might have misrounded some. And again, real quick guys, if I get 5.66, that is 5.7, yes? Okay, so we just all be careful about how we round things. Cumulative frequency, I told a couple of you guys how this works. As you move down the column, you just accumulate. So I got 5.7 so far. Added to this is 37.1, right? Add it to this is 74.2, is that right? And then add it to that. And of course that's going to be the same. Okay, so in the homework you're going to do that. I'm not terribly concerned about cumulative frequency, so I don't normally even include it. But you still got to do it for the homework. No big deal. And then finally,
Quick question.
yes.
So the relative frequency, should these two like add up the same percentage?
Yes.
So okay.
Yes. All right, guys. So be really careful in the homework, and I will do this sometimes also. If I said create a frequency histogram, which numbers are you going to use? Say again. Which numbers am I going to use if I want to create a frequency histogram?
The second step.
Second column, 11. I'm going to use these numbers. This one's a relative frequency, so I'm going to use those. So I think in the homework they do both. So be really careful which one to use in the right time. So how high do we need to go here?
40.
Yeah, like up to 40 or so, because the biggest one is like 37. So again, maybe we should go by what scale? 5, 10, 15, 20, 25, 30, 35, 40, yeah. Eights is beautiful. It's just as long as it's consistent and you use the space. Here's what I love. Somebody has this and they do some scale and then everything is down here. What good is that? Look at all the space you didn't use. Does that make sense? So you use a scale that you're actually going to use the space you've given yourself, right? You don't have to go up to 100 because then you're going to have all these smushed little buildings. It's not good. I need them stretched out so I can see what's going on. Now, considering most of us chose this way, what am I actually going to put here? 60.5, right? You got to go down a half, and again, it's that, I don't know what you guys think about my limit and my boundary, right? So I get a little below 61, so I go 60.5, and then the cool thing is once you get that first one, you just keep adding the width. The width is 4, so then I'm going to go to 64.5, 68.5, 92.5, and I can check 80.5, that's exactly this guy's boundary if I go up half. Okay. A lot. And then I should label this. What are these again? These are.
Hold up.
We gotta put father's heights, inches. And again, this is the relatively easy step now, right? Just the percentage tells me how tall to make these things. A little over 5, a little over 30, a little over 35. Oh my God, these buildings are about to fall over, John. Where's the other one? 20 exactly, and roughly 6 again. There. All right, that is gross, but it's pretty close. Let me see if you guys know this word. Have you guys ever heard of a bell distribution, a bell curve? Right? It's also called a normal distribution. Does this look roughly normal? Because what is it? Can somebody trace for me in the air what a bell curve looks like?
It's in the shape of a
Bell curve? Anybody? Everybody's like, I'm busy copying your shit. Bell curve is like that, right? So isn't this roughly bell curved? What is the major problem that keeps it from being more bell-shaped, more normal?
not symmetrical.
Yeah, this one should be lower or that one should be higher. But it is roughly bell curve. So the bell curve means low at the ends, high in the middle, roughly. And that's going to be a huge part of the semester is normal curves have certain attributes that make certain things easier to calculate. So it's really important to know when something is normal enough. This is really roughly normal. I like it. Which makes sense because the word normal kind of relates to the fact that if everything goes according to plan, like if there's no genetic deformity or there's no malnutrition or something, everybody's height should normally show up like this. Most people in the middle, a few people, short people, a few freaking tall ass people, right? Does anyone know somebody named Manute Bol? Was a basketball player way back in the day. I actually got off of a Southwest flight and I looked over and I saw this crowd of people and then I saw his head above the crowd. He was 7'7" or something crazy. So when people said when he sat down, his knees were like with his eyes. But yeah, so that would be certainly an extreme. And then of course you got the people that are down here, but most people would show up in the middle. Okay, I like it. All right. Let me tell you one little thing. I keep letting you out a little early. I'm going to do it again today. Because at the moment, I'm in charge of the tutoring center, the Math Study Center. And I keep meaning to take you on a field trip. Maybe I will eventually. I could do it today. Well, and the way the schedule is now, there's like 4 tutors whose hire paperwork has been delayed. So I have 1 tutor from now until 11, so I want to get over there and help in case it's busy. So that's why I'm letting us out early. So let's go ahead and go. Thursday I might take you on a field trip. We'll see.